Live from the Washington, D.C. area, it's the EmeraldPlanet. All the ecology news that our viewers want to know. Now, here's your host, Executive Director of the EmeraldPlanet, Dr. Sam Lee Hancock.
Hello and welcome to the EmeraldPlanet as we come to you on a week-to-week basis from Washington, D.C. and the United States as we look around the globe for those 1,000 best practices, the technologies, services, and products that are making a difference as we move through the 21st century. And as we add 2 billion new people to the planet by 2050, so in other words, we have about 9 billion folks, how we're going to be able to take care of all the basic infrastructure that they need and everything as far as the food, the fuel, the fiber, but also the housing, and how do we protect the environment at the same time. And we have a gentleman that's going to be telling us all about that. This is CJ Thouret. He is the principal and owner of what's called CruxHomes. And CJ, welcome to the EmeraldPlanet TV.
Well, thank you very much for having me.
Glad to have you here. Now you have something, I'm going to bring this up. This is really cute, but something called IceBox Challenge.
Yes.
What is the IceBox Challenge and why is it actually important?
Okay, the IceBox Challenge is a public science demonstration that is designed to take the somewhat obscure concept of high performance building construction and make it tangible. So we don't really spend a lot of time thinking about, what's inside of our walls, right? Or how that affects, our everyday lives.
Or the energy efficiency of your roof. Or,
yeah, exactly.
Is there insulation in the floor? All these kinds of things.
Right. Unless you're really struggling financially, chances are you never really think about your heating bill or your cooling bill. It's something that you pay and it happens, but you don't, it's not really probably too painful and it just sort of happens. The IceBox Challenge pits standard construction against high performance construction using the same building materials to demonstrate that it really does make a difference, and we show it with ice. So we put 1,800 pounds of ice in each box and we let it sit for three or 4 weeks, and you get to see the impact on the ice of what the building did. How did it perform? Did it prevent the ice from melting? How much? What's the difference between the two boxes?
Yeah, and you're talking about ice, but actually we're looking at these two buildings here. These are really the ice boxes, right?
Yes.
And now they're really to show something much more profound than this. It's something what's called the National Building Code versus what's called passive house, which is a very highly energy efficient and low greenhouse gas emissions and all that. So how through these two ice boxes are we actually demonstrating that so that people can actually kind of feel, oh, okay, something is really going on here, and what is that something?
Yes. Okay. So passive house building methods are the pinnacle of construction methods. You're designing a building. When you design a building at passive house standards, you're basically creating a structure that will use the least amount of energy possible. The building codes were developed that most of us use and live in were developed during a time when energy was almost free. So, and homes had to be built quickly. So because of the expediency and the low cost of energy, there was not a lot of concern for energy efficiency. But you see in the 70s, during the energy crisis, that became an issue. We start getting super efficient buildings. It didn't really take off in the United States. Germany took the lead at that point, created the Passive House Institute. And so anyway, so there's that piece. As that relates to the IceBox Challenge, I started to talk about it a little bit. They're built with the same building materials, the same studs, the same plywood, the same type of insulation, the same material used for an air barrier. The only difference in materials is the passive high performance structure has a triple pane window, and the standard code box has a double pane window that most of us have in our homes.
Looking at the standards by comparison, tell us what this actually means. Now we're really getting down into the nitty gritty of what this is all about. Got these cute houses, talking about ice. We're going to see the ice in just a little bit, but what is this comparison all about?
So it's about construction methodology. It's about and again, because we're using the same building materials, but we're just applying them differently, and we're getting these dramatically different effects. The Philadelphia installation, after 4 weeks, there was no ice left in the code box. There was 300 pounds left in the high performance box with the same building materials. So it's really methodology. So more insulation, tighter air sealing, better doors and windows. And then there's some other design principles that go beyond that don't really apply to the IceBox Challenge. But the IceBox Challenge is to point a big blinking arrow at, this is something that we can do. These are the possibilities. You don't have to just live in a standardly constructed home. You have options, and there are some really fantastic reasons to go after those options and
it's like the old Hawthorne effect. What you're doing is you're putting a big spotlight on what this is, what it can be for you, and also how you're going to save money. But even more importantly to that, CJ, is how does it make your house much more comfortable?
Yes.
I think that's what it's all about. So looking at these two ice boxes here, we have one that's all nice and blue and green. The other one is, a little more visible colors, very vivid.
Yes.
So what is the difference between the two of these? What are we actually looking at in these? And we're going to show different cities and where these have been demonstrated.
Okay, so the box with the red colors is the code box. It's got 2x4 walls. It's got one 3-inch layer of insulation in between the studs, like we would have in most of our homes. It's got the double pane window. It's got an air barrier installed, but it's not sealed. And it's got a plywood roof. So, standard construction methods that you would see in most homes. The passive box, the blue one, has thicker walls, 3 times the insulation, a triple pane window. The air barrier is installed in such a way where it's actually sealed all the way around to be very close to airtight, because you lose a lot of thermal energy just by transferring air inside and out of your building. So that's...
we're looking at different cities here. We're going to go back. Understand this is in Philadelphia, and then we have New York City.
Yes.
So why are you choosing these major cities in order to have these demonstrations? And then we have the one here for Washington, D.C.
Well, that is an interesting question, or it's got an interesting answer. It's somewhat serendipitous. The boxes were built. It was sort of put out there that these are available. And the cities that the IceBox Challenge has gone to has been based upon interest. So people in New York wanted the IceBox Challenge there. People in Philadelphia wanted the IceBox Challenge there, and same in D.C. In fact, in D.C. it was fantastic. We were sponsored by the European Union, which...
and I tell you, that really resonated with a lot of people, because here you have the European Union working, with Americans in sense of saying we have to do this because this is really a global issue.
It certainly is.
As far as, climate change and, bad environment, what happens, it goes everywhere else.
Yes.
So we really need to do something.
Yes.
So why have it in the public parks like this? We're seeing very open areas where these are actually being set up, and what is the purpose of that?
It's just to put that spotlight on the issue. Most people don't know what passive house is or what it means, or that there is such a thing as a high performance home. I think if everybody knew how much of a difference all that extra insulation would make, then we would see it everywhere, because everybody will, I want my house built that way. I want a high performance house. I don't want a standard.
Well, and they're quieter, they're more comfortable.
Yes.
Literally, they're easier to live in.
They are.
Because, they are very quiet. And so it's amazing. And but these are really cute.
Well,
yes. Why cute?
Well, you want people to look at that and wonder, what is this little box doing here in the middle of Farragut Square? Why is this here? And it's got cool painting, so that people come and look at it. And, there's signs on the side. There's brochures there for people to take with them. There's a website, eastcoast.iceboxchallenge.com, so people can, share it. They can go online. They can guess, how much ice is going to be left. They can really interact with the installation and the demonstration.
Now, what we're using this picture for, it's a little bit different than what you originally used, but this is where you actually had these platforms with the ice in that.
Yes.
So both of these houses actually had the same identical amount of ice. You
Yes.
weighed it, so everybody knew that they were exactly the same.
Yep.
And so the outcome of this was to demonstrate what?
Okay, so we we set up the 2 boxes. We put the ice in. They come in 300-pound blocks. So we put in 1,800 pounds of ice, and then when we do the ceremony at the end, where we reveal how much ice is left, we set up little PVC frames that actually outlines, this is how much ice we started with. So you can see, very readily, this is how much more the ice melted in the standard box versus the passive box.
Yeah. Now these passive boxes, they really are a box. So there's no
Yes.
electricity in there.
No.
There's no heating, air conditioning, ventilation. There's no fans. There's no anything.
Nothing.
So they're just
No
sitting
cheating.
there.
No
So they're
cheating.
really just sitting there in the parks. And so whatever it is, it's going to
Yeah.
be. So if you have a rainy day and it's cool, it's going to be a little less,
Yep.
as far as what's going on inside. Other days when it's, we had 100, 105 degree heat, there's a lot going on in those boxes.
Yes, and actually, in Philadelphia, Penn State was very helpful in helping us with the IceBox Challenge installation, and gentleman, Mark Stutman, actually donated a couple data loggers, so we were able to track the temperature inside and outside of the boxes. And you can see a graph. If you go on to eastcoast.iceboxchallenge.com, you can see the graph of this is what the outside air temperature was, and this is what the temperature was in the passive box, and this is what it was in the standard box. And you can see they track. There's no tricks.
Yeah, yeah.
It's all just based on
It's
thermodynamics.
sitting in the park and it's out there.
Yeah.
But this is Washington, D.C., I believe we have in front of us, because I was actually there for the big reveal,
Yes.
which they made this big, deal out of this, the drum roll and all that.
It was a good day.
But tell us about the difference between what we have here as far as the passive houses on the bottom and the code houses on the top.
Yeah.
And you're saying, it looks kind of similar, but it's totally different.
Yes, I unfortunately don't recall right off the top of my head the actual numbers in pounds of ice, but it
was significant because I was there for that, because actually the code house, the ice was actually hollowed out.
Yes.
So even though you had a little bit of mass left, actually there was not much there.
Yes.
I mean, it was just, as you can tell in this photograph,
Yeah.
it really was just hanging on, where you have a real solid mass as far as
Yeah.
the passive house is concerned.
DC was a little bit shorter, so the difference wasn't as dramatic. If those 2 boxes could have sat for another week, you would have seen a bigger difference. In Philadelphia, after 4 weeks, there were 300 pounds of ice left in the passive box, and the code box was completely gone.
Pretty empty. What do you see for the expansion as far as the IceBox Challenge over the next 5, 10, and 15 years?
Well, I'm hoping.
Gotta be quick.
Yes, I'm hoping that more people will know about it. More people will call for demonstrations of environmental science in their communities.
CJ Thouret, principal owner, CruxHomes, thank you for being with us as we look at the IceBox and EmeraldPlanet.
I surrender.
All right, pal. Get ready for the day, buddy.
Hey, Dad. Hey, Dad. Do we have a gun?
What's up?
Do we have a gun?
Maybe you can make retirement happen. After all, you made this vacation happen,
Double points with every purchase?
cleverly merging promotions,
Love it.
cross-referencing travel sites, and booking all your flights with those.
Vouchers. I got us bumped.
They were like, oh, but now they're like, aloha. You aced this vacation. Now get the tips you need to get on track at aceyourretirement.org.
I tried Oxy at a couple of parties. I thought I had it under control. I didn't know it'd be this addictive. I didn't know how far I'd go to get more.
Opioid dependence can happen after just 5 days. Know the truth, spread the truth.
What to expect when you're expecting.
Like here?
A teenager.
Today, I'm going to show you how to team-proof your home. First step, hide the car keys, preferably somewhere they would never look. Challenges will come up. Be ready for them. Hi, honey.
Ready for the... Mom, you don't use mannequins in the mannequin challenge.
You don't have to know it all to be a perfect parent. Thousands of teens in foster care will love you just the same.
We're back to the Emerald Planet. Here again, your host, Dr. Sam.
Hello, welcome to the Emerald Planet as we come to you on a week-to-week basis from Washington, D.C. as we're looking for what we call the best of the best. Those 1,000 best practices, technologies, products, services, and the people, of course, that are making a difference as we go through the 21st century. And as we add 2 billion people to the planet, there's going to be a whole lot of construction that's going to have to go on to house these people. Millions of units all over the world. And as we know that there's great expansion of the population on the African continent, Southeast Asia, Latin America, many other places. And so the whole thing is that we have to take care of these people. And how are we going to do that? Are we going to provide just existence as far as these structures are concerned? So people, it's cold in the winter, they suffer through the monsoons or the hot weather. How are we going to be able to take care of them? And a gentleman sitting right beside me has been taking care of all those issues, addressing those for a number of years. This is C.J. Thouret. He's the principal and owner of CruxHomes. And welcome to the Emerald Planet.
Thank you. Thank you for having me.
Tell us a little bit about the mission and vision of CruxHomes. Then we want to get into really the gist of all this, the passive house, what is it, why it works, and why this really may be the structures or the building processes of the future.
Okay. Well, our primary mission is to make quality, energy efficient housing more attainable, sustainable housing, if you will. There are a lot of options out there. The technology has been around in various forms for a long time. It hasn't really taken off. I think there are, various reasons for that, but I think CruxHomes is one tool in the toolbox to provide energy efficient homes for people who need them.
Yeah, and this is a very unique structure that we have here, unique design. But my understanding is this only takes a couple of days to do all of this?
Well, in the field.
Yeah.
So that's one of the benefits of the design, which I need to give credit to Brian Waite. He's a retired mechanical engineer from the UK. It's his design.
United Kingdom.
Yep, I am his North American representative, if you will. He and I have an agreement. But so it's his design, and the arches are fabricated ahead of time off-site. But the images that you have are from a home built in Scotland, and those arches were erected in about 2 days.
Yeah. Now looking at this, I mean, this is a huge house, and we're going to see this. This is really very beautifully done and all that. But how do we translate this to the millions of units that we're going to have, across the African continent, 54 nations?
Yes.
You've got 30 plus in Southeast Asia. You've got all the countries, 34 in Latin America.
Yeah.
And so we're going to have things that are much smaller,
Sure.
much more, cost effective, but at the same time, very energy efficient.
Yeah.
So how do we combine all this with this type of structure?
Well, one of the great things about the CruxHome design is the flexibility. There is no one set way to do it other than the arches. They're kind of sort of a blank canvas that you can do what you want to do with them. So if you want to make a smaller one, make it smaller. If you want to make a bigger one, make it bigger. If you want it to be a multi-family home, like a twin, or put a bunch of them side by side, you can do that as well. I'm not naive enough to think that this is what everybody in the whole world is going to live in, but this is an option. I think it's an excellent
Well, I mean, that's
option.
what we're talking about. I mean,
Yeah.
that's what EmeraldPlanet is that we're always introducing options for people so that they have, as many choices as possible. But looking at this is something that, looks like it's simple enough that this could be replicated in many developing countries.
Yes.
And so that you're actually adding new green jobs, using local materials, local labor, all these other kinds of things, instead of what we think of a standard stick-built house for the United States, which takes, you know, we're trying to export. Actually, what we want to do is to have, you know, so people can actually erect their own homes and live in their own homes.
And that's one of the goals of CruxHomes. It definitely simplifies the construction process. You know, one of the difficult things about, you know, a standard stick-built home that we think of in the United States and North America is, you know, where like the wall meets the roof. Complicated things happen there. That's gone. You know, you tip the arches up, you get them in place, and then you go from there. But that's definitely one of my goals, is to create an opportunity for people that want to build their own homes to do that, and I will you know, support them as much as they need it. So if it's just, you know, here's a set of drawings and the arches and go to it, that's great. If they want me to come and, you know, guide them, that's fine. If they want me to help do some of the building and they do some of it, that's okay. And if they want a turnkey project where I deliver it soup to nuts, I'll do that too.
Yeah, looking at this though, really what we're talking about is the passive house. So what is passive house?
Okay.
And how is that really important for where we're going in the future? Because again, we're going to have to produce hundreds of millions of units of housing all over the globe. And we want to do it, and a lot of it's going to be in that tropical belt all the way around the globe.
Yeah.
So it's very hot, it's high humidity and all those things.
Yeah.
So how does the passive house start addressing that? But let's talk about the cost. We're looking at something here, space heating. Of course, tropical belt, you don't have to worry about that. Yeah. But there, they need cooling.
Yeah, sure.
I mean, to really be comfortable.
Well, you know, if you live in the tropics and you live in a passive home or a high-performance home, you're going to need a whole lot less cooling. And that's one of the beauties of...
See, that's the whole flip side of this whole, you know, you got heating and you, of course, the cooling.
You can think about it like a thermos, okay? If you put something hot in there, it's going to stay hot. If you put something cold, it's going to stay cold. And what the thermos is doing, it's keeping the inside in and the outside out, and that's a big part of what passive home construction is. There's a few basic principles. One of them is super insulation, so you have, you're minimizing a heat transfer between the inside and the outside. One of them is tight air sealing, again, to minimize heat transfer from inside to outside. Because you have that tight building, you need to have fresh air introduced. So energy recovery ventilators are used to maintain fresh air in the building.
We're going to show these in just a few minutes, but we're looking at the cost feature here of all this.
Okay.
Of course, in many of these homes overseas, there's very little water. They're not doing a lot of water heating and all these other kinds of things.
Right.
So here we're looking at something that's more sophisticated. But the whole thing is through the passive houses to be able to lower those costs.
Yes.
And then put, you know, the investment in the envelope itself and the structure.
Yeah.
But also we need to think about the environment.
Yes.
And reducing greenhouse gas emissions in any way possible. And many people think of cars as the main culprit as far as, you know, emissions, all that. Actually, it's the homes we live in and buildings actually is the greatest percentage of all that.
Yes.
So how do we, through the passive house, how do we reduce this greenhouse gas emissions?
So there's a few ways that we're doing that. We're lowering our day-to-day energy consumption.
Which we have in this chart here. We're going to show some of the ways of doing it.
Yes. Now, you know, there are other options out there. For instance, you could, you know, in developing world, you could 3D print homes with concrete. Concrete has a big carbon footprint. You know, the CruxHome design is using a wooden arch, so you're actually sequestering carbon in the process of building a CruxHome. So that's, you know, that's part of it as well. But the big thing is lowering your day-to-day energy consumption. That's really where we're getting the biggest bang for our buck.
Now, looking at the structure here, what are we doing here that's different than a standard, what we call a national code home?
Sure. Okay, so we have the arches. Okay.
Now, looking at this home that we have right in front of us, this is a diagram of kind of a standard house, if you will.
Okay. Okay. So this is an example of the passive house principles. So we talked about super insulation, we talked about air sealing, we talked about the energy recovery ventilation, triple glazed windows, high performance doors and windows, the orientation of the building. So, you know, which part of the building faces south, how many windows do we put on that southern exposure so that we can manage our heat gains and our heat losses. So, you know, being cognizant of how the building interacts with the environment. These are the fundamental principles of passive home construction.
Now looking at this extraction key here, what is this all about?
Okay, so this is a diagram explaining the operation of an energy recovery ventilator. So what we're doing is we're taking fresh air from the outside of the building, we're bringing it inside constantly. We're taking stale air from inside the building, we're sending it out of the building constantly, you know, from your bathrooms, from your kitchen exhaust. And what we're doing is we're allowing those streams to cross in various ways depending upon the specific kind of equipment that you have. And we're taking the energy from the inside and we're using it to pre-treat the air from the outside. And you can get, you know, 85, 90% efficient energy recovery ventilators or heat recovery ventilators that will give you 100% filtered fresh air, and you're really losing almost no energy in the process.
Yeah, that's just amazing. And we're looking at one of these units right here. So you're looking at taking the return air, you're exhausting that, then you're bringing in fresh air.
Yeah.
And so you have this constant exchange going on?
So this is a diagram of the sort of the best way to do it. It's you know, enthalpy based. It's not just heat recovery, it's energy recovery. So you're getting your sensible and your latent at the same time. And what you're doing is this wheel rotates, and the exhaust air and the fresh air pass, and the wheel is transferring energy and a certain amount of humidity. And this is the most efficient way we have to introduce fresh air into the building and lose the least amount of energy.
Now looking at this house, this is one of the finished homes that you have here. So you're taking this passive house design, you're putting into this. So this is actually that structure we saw with all those you know, different ways as far as, you know, cutting energy consumption, reducing greenhouse gas emissions, reducing amount of energy you need. All that is then incorporated into this one structure. Is that correct?
That's the idea, you know, and incorporating it as much as you can. You know, everybody has, well, not everybody, but most people have financial constraints, and so maybe they can't get the creme de la creme triple pane windows, you know, manufactured in you know, in Europe somewhere. But the idea is to do the best that you can, and you know, I started to touch on it a little earlier. One of the beauties of the CruxHome design is that it's kind of a canvas. Like, you can do what you want. You can use. You have a big cavity in the wall that you can insulate with whatever kind of insulation you have at your disposal or can afford. You can choose the windows that you put in. You can choose how it sits, you know, according to the sun and those sorts of things.
Now we're going to leave this up because this is actually snowing. You can't see any heat escaping out of this, because if not, it'll all be melted on the outside. Yes. But what do you see for the passive house over the next 5, 10, and 15 years as far as these principles being used regardless of, you know, the structure it's going into? How do you see that expanding?
Well, I'm very optimistic. The data that I'm aware of is that every year we're doubling the number of passive structures that we're building. And I see that.
This is mean for the country?
I would say North America, right. So the United States and Canada both. And I think that's going to continue. And you know, the more people know about the options and that they have a better alternative, the more we're going to see high-performance homes being built.
C.J. Thouret, principal owner of CruxHomes, talking about passive house, the efficiency of that as we create the EmeraldPlanet.
So, I just moved in with this family, and it's embarrassing. The little one, he likes to go outside and crawl around in the giant litter box. I don't know what he's doing. I mean, I was born and I knew how to use the litter box. Look at that! That's disgusting! Oh, poop already! You're making me nervous. Oh, okay, I can't look at this anymore. I really hope he grows out of this, for his sake.
So how was work?
It was 1,300 hours. My math class from 302 was in the trenches. Davy Roth had it the worst. Fractions were coming at him left and right. He just didn't get the damn things. 2 days ago, I tried to teach him what 1/4 of 1/2 was using different sizes of blocks. Yesterday, I tried again by dividing up pizza. Both missions failed.
Oh, no.
But today, I was ready. I created a combat math game where the only way to beat the enemy is to out-fraction them. Davy conquered every last denominator. My game was so successful, the principal is deploying it to math squadrons all over the school.
Anywho, how was your day?
Oh, today my boss treated the office to salad wraps.
Salad wraps.
I know.
150 over 90.
180 over 111.
160 over 110. I had a stroke.
This is what high blood pressure looks like. You might not feel its symptoms, but the results from a stroke are far from invisible or silent. If you've come off your treatment plan, get back on it, or talk with your doctor to create an exercise, diet, and medication plan that works for you. Go to loweryourhbp.org.
If I would have followed a treatment plan, I would not be in this situation.
We're back to the Emerald Planet. Here again, your host, Dr. Sam.
Hello, welcome to the Emerald Planet as we're looking around the globe because we're looking for ways that we can provide really energy efficient housing at the same time to make it low cost and to accommodate as many people as possible. And yet we have to experiment and try to determine what really are the best structures that can be used and how to make it fit into the modern urban environment. Many people don't realize the United States we think of as a big wild place and you got horses and cows and buffalo running all over. Actually, we're a society is now 80% urbanized, 80% urbanized. And if you think of a country like Brazil, where you think of the Amazonia and the jungles and all that, it's 87% urbanized. So many of these very large countries like the United States, over 300 million people, almost 320 million people, most of them are living in urban areas. But we're going to have all these new people joining the planet. We should be about 9 billion people by 2050. And so how are we going to do all that? And I have someone sitting right beside me that's not only been thinking about all this, but it's been doing a lot about this. This is Laura A. Blau. She's an architect, principal of her own companies. And she has BluPath Design and also GreenSteps. And we're going to talk about some of those things. You see the logos that we have up here. But anyway, it's really exciting what you're doing, Laura, in the city of Philadelphia, the east coast of the United States. And tell us a little bit about the BluPath Design and also GreenSteps. Those are very interesting names that you have. And then why the blue and the green?
Oh, well, Laura Blau. Blau means blue in German, and my husband partner is Paul Thompson, so Path, P-A-T-H.
Right.
So we're BluPath, and that's our architecture firm and passive house consulting and designing firm. GreenSteps is a firm we originally created that was doing energy audits in the recession and also doing sustainable consulting, and just this last year I changed it into a construction management, owner's rep, and contracting firm for passive house in order to actually also be part of the implementation of the design, because it's really integrated design that is needed to make a really good building.
Now we have this this photograph here, and of course the byline. You know, it takes a team to do all this. But as far as the passive house, what is passive house? Why is it so important? And how is that actually maybe a path forward to the future, not only for, you know, very high-end houses, which most people think it would be, but also how this could be applied across, you know, many different types of structures.
Right.
And around the globe at the same time.
It is the most rigorous standard on the globe for energy, and it's a standard. It's not a checklist. It's a standard. You either make it or you don't. There's two certifying bodies: the International Passive House, where the standard originated, and the Passive House Institute of the U.S., which broke off from International around 2011 or 12, mostly so it could align itself with the Department of Energy, do research with them, and the protocols would align more with U.S. protocols. All right. So basically, I say it's Energy Star on steroids. It's 5 times more efficient, Yes, five times more efficient than an Energy Star building. It's
now, but what is Energy Star? Because most people are not going to know what an Energy Star is either.
9 times more airtight. So an Energy Star building is basically a building that is about 15% has to be at least 15% more efficient than code. And code, of course, is the minimum health safety standard. Any less than that, and you should be going to jail, right? So you wouldn't buy a car based on it just barely making it through safety standards. You want a car that's safe, right? So
now let's look at this. Okay, we have a structure here, and we're going to walk through this whole thing as far as what we're looking at, talking about passive house, why it's important, how does it work, and all that. But you look at this house, and there's so many design principles put in this and ways of saving energy, making it more comfortable, quieter, and all this. But this is in the middle of a very busy neighborhood.
it is. This is
In
the
the Italian
market.
market area in Philadelphia, which is really extremely busy. And there's a lot of these row homes in there. So tell us what we're looking at here, and why did you want to start with this? Because this is the first passive house.
This is the first.
For that.
It's not the first passive house in Philadelphia. It's the first single-family passive
Yes,
house. There have
exactly.
been some multifamily and also some modular passive houses, but it's the first single-family custom-built passive house. It's built on top of an old 7-Up warehouse in Philadelphia, and it's right on the cusp between the mercantile part of the Italian market and the residential center. So it's sort of this funky hybrid. So the big warehouse is the owner's big shop, who likes to work on cars, and he has actually a 12-foot lift in there. And then this modern home sits on top of it with a beautiful double height space. And
We're gonna see some
that
of these.
red line that you see around that drawing is where the air barrier is. So we didn't include the garage in our pass. It's not conditioned. It isn't
We
heated
got it.
and cooled. So it's just the part of the house that is the conditioned space.
Yeah. Now looking at this, this is really, in some ways, it's very energy efficient, but also it's a very futuristic design, and you're really inviting the outside. So it's almost like the house is just this palette that sits there, and then the whole neighborhood's invited into that. So how did you do that, where you're incorporating the neighborhood, yet this very advanced building principles and standards at the same time?
Right. Well, first of all, there is no style to passive house. It's any kind of building. It could be a hospital, a church, a multifamily, a school, a house, affordable housing, lots of that happening in Pennsylvania right now. This is a custom home, and we have the directives of the client that we have to satisfy. So it's kind of I call it a suburban-urban hybrid, because in many ways you could take this house, instead of being on top of this warehouse with a front deck and a rear deck, you could put it on a beautiful piece of land in the middle of the country, and it would work there too.
Correct.
And that was part of the directive. It's got gorgeous, beautiful double height space. The sunshade that's on the front of it, which you saw earlier, is shaped, and sun studies were done to make sure it allowed the winter sun in but kept the summer sun out. And it's perforated metal with images from the client's honeymoon in Hawaii. It's trees from the honeymoon.
Oh
so
my gosh.
basically the
That's
house is shaded by trees, metaphorically, and it plays beautiful shadow patterns on the wall.
Yeah. Now looking at this, many people think of when you're doing this, you're going to have this tight house. The house can't breathe, and houses don't breathe. They leak air, or whatever. And then as far as too tight, you really want it so it's very tight, so that you can control the what you're conditioning, that
Right.
you keep and use it as much as possible, whether it's heating and cooling. So, but why do people have these misconceptions that a house is sitting there with lungs and it's breathing and doing all these things, which really is not
if
true?
you were talking about a house from 100 years ago, the way it dried out, and actually houses don't have to breathe as much as they need to sweat. They need to dry out. All houses, like today, it's rained and it's been humid, right? So the house has dampness and moisture. You take showers, you cook inside, you create moisture inside. Those things go into the walls, and they have to dry out. If they don't, you get mold, mildew, and problems. When you make a super airtight house, instead of having that air come in willy-nilly through leaks in the building, bringing mold, mildew, the mouse dropping dust in those walls, you want to bring it in a controlled way through this energy recover or heat recovery ventilator that CJ just spoke about in the earlier session. When you do that, you used a balance system. So you're bringing in exactly the same amount of air that you're exhausting and trading the energy to preheat and pre-cool that air so you're not losing energy. And these are certified pieces of equipment by the Passive House Institute or US Passive House, which means they have to be a certain level of efficiency. They have to be a minimum of 75%. The ones that I generally use are 85 to 95% efficient. So you can imagine how efficient these things are.
Yeah, and also how much money you're saving for the homeowner. But looking at this, these are absolutely beautiful features in this particular home. But you know, you have really thick insulation. You have the windows that are properly spaced according to the orientation to the sun, north, south, east, west, and all that. So what we're looking at here, how do these principles come to play? And what does it really mean to the comfort, you know, in the structure? So they just kind of forget about it, they relax, they enjoy it, but yet it's still working for them.
Yeah, I mean, you know, you live in this like any normal house. On a beautiful spring day, you can open the windows like any house. I mean, there's this misconception you can't open a window in a passive house. That's just silliness. You live in it like any normal house. What you get is these thicker walls, which means you get to have wonderful deep sills. In the case of our design, we splayed the windows in certain directions to direct light into the house and used it as an element to play with design. You can do wonderful window seats. And because the windows are triple pane, they perform as well as a typical wall, right? So there's not a cold draft there, right? It really makes the house comfortable. It also means you don't have to bring heat right to the window because you don't have a draft there. So you use less ductwork because you only have to just bring it to the room, not all the way, that next 20 feet all the way to the wall. And so these amplified and synergistic efficiencies amplify. So in a passive house, 1 + 1 + 1 doesn't equal 3, it might equal 6, right? Because each of these things allows you more efficiencies and they play upon each other and amplify.
Yeah, we're losing time. This is absolutely fantastic, but tell us what we're looking at this chart. A passive house versus a standard stick built, and we're going to finish on this.
Right, so if you think about the cost, basically if your use is consistent, but you have a standard home, you're spending more, and as cost of energy goes up, that amplifies exponentially, right? So that green bar at the bottom is how much more your passive house costs over time, and the red bar is how much more your standard home would cost over time, and thus you have a great deal of savings.
Yeah, and the whole thing about this too, looking at this, Laura, is that you know you want to have this intersect between the savings, the comfort, and also not putting all these greenhouse gases into the environment.
Well, in addition to that, it's resilient, because if the power were to go out, it would probably not go much below 60 degrees. It's happened for 2 weeks in a house, I think it was in Vermont a few years back in a big storm. You also are only using local labor. It's more durable because the way buildings deteriorate is often through freeze-thaw.
We're going to lose our time, and I want to ask you, what do you see for the expansion of passive house over the next 5, 10, 15 years? We got to be quick.
We have to have banks, appraisers, and insurance companies understand the value in order to appraise these properly. We need more contractors to be trained. We need more designers to be trained.
And this is Laura
and
Blau,
we need more people to know about it.
Principal Architect, Blue House, and GreenSteps as we create the Emerald Planet.
This is the story of a boy who is very sensitive to lights and sounds. So he built secret hiding places where nothing could get in. The boy didn't like looking people in the eye. It made him feel uncomfortable. One day, he found out he had something called autism. His family got him help, and slowly, he learned how to live with it better.
Early intervention can make a lifetime of difference. Learn the signs at autismspeaks.org.
What do you think you're doing, Kevin?
Was just gonna drive home.
There are several warning signs present that you shouldn't be driving.
Like hearing voices?
Like your text-to-emoji ratio?
Oh man, the selfies. Selfie, nailed it.
We all have warning signs that let us know that we're probably not okay to drive. Mine is pretending to be your subconscious.
Craig, come on man, let's put a ride home.
Being
is an adventure full of special moments.
A cruise?
Surprise!
Unexpected moments.
I got this.
And even awkward moments.
Okay, Dad, thank you.
But every moment you spend with your kids, even the smallest moments, can make the biggest impact on your child's life. So take a moment to be a dad today.
So, I'm kind of new here, but I've noticed a trend. My human does this funny thing where she goes around and gets all my toys, and then she hides them in that basket by the door. You know, but it's always the same basket, and it's always in the same place. And then she acts so surprised when I find them, but, you know, she's putting them in the same basket. Again. It's like, hello, that's where you put it last time. You were the worst at hide and go seek.
We're back to the Emerald Planet. Here again, your host, Dr. Sam.
Hello, welcome to the Emerald Planet. I'm Dr. Sam Hancock, the President, Executive Director of EmeraldPlanet, EmeraldPlanet TV. And we come to you on a week-to-week basis from Washington, D.C. in the United States as we look around the globe at 144 different nations. We're looking for those 1,000 best practices, technology, services, products, and the people, of course, that are making a difference as we go through the 21st century. And as we add another 2 billion people to the planet by 2050, how we're going to be able to provide housing for all of them, as well as, you know, the power, the water, everything else that it needs to take for human life. But actually there's going to be millions, maybe hundreds of millions of units of new housing that's going to have to be built. And I have someone sitting right beside me as an expert in all that, and she's been doing this for a few years.
Almost
this is
10.
Oh, giving a secret away. This is Laura A. Blau. She is a principal and architect for BluPath Design, also GreenSteps. They're working on the passive house as consultants, as architects, and then also construction management. And so you're putting all this together, Laura, in order to move this passive house concept going forward. And most people think of passive house because my Rotary Club, we built the first passive house with the Habitat for Humanity in the United States, and it's, you know, just a few miles from where we are right now in Washington, D.C. But you've really taken this the next step where it's going to be retrofit. Why retrofit? And you gave me an amazing number before we come on the air. Tell us about new versus retrofit and where the future lies as we go towards 2050.
Right. So we only build about 300 to 700,000 buildings in the United States.